Okay, welcome back, students. Today is our test corrections for Chapter 8 test. It's kind of nice to see people did really well on the test. So let's get started. Determine whether the polygons are similar. So I've got small side, big side, small side, big side. So I compare my small side to my small side, and we'll see if the scale factor is the same as my long side to long side. So one of the things some students have been using is the Desmos scientific calculator. And so, you got 10/15ths. So if we get in here and we go to scientific calculator, and we can just plug in the fraction, and it will give us the simplest form of that fraction. So, for example, we have 10/15ths. And so right now it's giving us a decimal over here, but we can change that to a fraction, and it's 2/3. So 10/15ths is 2/3. And then our other fraction is 14 over 21. And that in a fraction is 2/3. So, you know what? I'm going to pause this video because this mouse is terrible. I'll be right back. Okay, apologize about that. I have never actually had a mouse that functions so poorly. So, there we go. I put 10/15ths into that scientific calculator. I got the simplest form is 2/3, 14/22. The simplest form is 2/3. So yes, determine whether the polygons are similar. Yes. And if you went so far as to give me the scale factor, it is 2/3. Okay. Check out number 2. So we have a parallelogram. Small side, big side, big side. So we take our small side and our small side, and we see if it's going to be the same proportion as our large side to large side. Now, if I put these into the calculator, divide both these by 5, I get 1/3. Divide both these by 7, I get 1/3. So yes, in fact. So if I put them into the same scientific calculator, this is what I would get for the simplest form. So yes, they are similar, and they have a scale factor of 1/3. All right, so let's check this one out. Now, you're going to have to make sure that you do this correctly, because if you notice, they're upside down. But we still have the legs and the bases. You just got to make sure you compare the correct bases, the smaller base with the smaller base. So we'll see if these have the same scale factor. 12.4 is the legs. This isosceles trapezoid. So put that over 15.5. Then we have the small side is 20. And so that would be 25. And then the longer side is 28 and 35. And this one I found it actually quite helpful to go over to the scientific calculator with these numbers. First number is 12.4. 12.4 divided by 15.5. And it's showing me my fraction, which is 4/5. And then 20 divided by 5, which is 4/5. Okay, things are looking good. Things are looking really good. And my last one is 28 over 35. 28 over 35, 4/5. So yes, these are similar, and we have a scale factor of 4/5. All right, let's look here. Find the following, the scale factor. So let's get this one full screen. So our scale factor for these two, pick any similar sides. So let's take, no, that's missing. So we'll go 10 to 15. So 10 to 15. If I simplify this, divide both by 5, I get 2/3. So my scale factor is 2/3. If you had 3 halves, you would have got, if you did 15 over 10, you get 3 halves. Same difference, depending on which way you're going. EH would be this long side. So I have a scale factor. I already know my scale factor is 2/3. So my scale factor is going to equal my small side, so x, over my long side, 24. Butterfly, 3x equals 48. Divide by x on both sides, and I get x equals 16. And then I want to find AB, this length right here. So I have my scale factor. I already know my scale factor. So my short side over my long side, so my short side over my long side. 18 equals 2x, x equals 9. All right, let's move on to number 7. So these ones are just looking for which angles they're congruent with and which line segments are congruent. So angle P right here is the same as angle L. Angle M, where's angle M's right here, so that would be congruent with angle Q. And then I'm looking for MN, the long side, is equal to RQ, just like LM is equal to PQ. Oh, geez, I'm writing all these off of the board. I'm sorry. I got angle L, angle Q, and line segment PQ. And number 10, find the value of x. So here's x right here. It's on the small side. So we have, for number 10, we have x minus 2 is to 12, as we need some other side length. We have 18 to 24, 27 to 36. Let's go 18 to 24. As 18 is to 24. So I do my, so I have 24 times x minus 2 equals 18 times 12, 216. Okay, I'm going to move this up a little bit so you can see all the math. 24x minus 48 equals 216. 24x equals 264. So divided by 264 divided by 24, x equals 11. So for number 10, x equals 11. Now for these ones, gosh, it's too bad the problems are way down here and the answers are way up there. Determine whether triangles are similar, write a similarity statement. So I just want you to know how we know they're similar. So we got 60, 79, so this is equal to this. And then if I did 180 minus 60 minus 79, I get 41. So this angle is 41. So look, I've got 41, 41, 79, 79. So these are similar. And how do I know? By angle similarity theorem. Okay, now let's check these out. I've got this long side. I'm going to do some math here. So I've got 16 is to 20 as, so this is to this as 20 is to 26 as 12 is to 15. So I'm going to see if those are the same. Divide both of these by 4. Divide both of these by Oops, this one's backwards. 16 to 20. 20 to 20. Oh, no, it's not. Okay. Let's see. If I divide both of these by 2, I get 10/13. Uh-oh. Not looking good. Divide both of these by 3. There's our outlier. So these are not. Nope. Not similar. All right, let's check number 13. 48. So those are the same. Now let's do the same thing we did for number 11. So we're going to do 180 minus 48 minus 77 equals 55. We'll see what. Nope. There's only one angle that's the same, right? This is not equal to either of these. So, nope, not similar. All right, number 14. You're going to want a piece of paper, and you're going to want to draw this out. So, for number 14, we've got right here. We've got 8, -6, 8, -6, 1, -3, and 1, -9, all the way down here. So there's our one triangle. Then we do -7, 1, 0, -2, and 0, 4. So there's our two triangles. And we have to explain the transformation. So what is the transformation from here to here? Well, it flips. It flips and you move it, or you move it and it flips. So what we could do, let's flip it so it reflects across y-axis. So that would put it right here, and then it moves right, and then x plus 1, and then y. So if it moves right, and then the point would go 1, 2, 3, 4, 5, 6, 7, y plus 7. So there's your transformation. Reflects across y-axis, x plus 1, y plus 7. All right. On to number 15, your geometry class. Goes outside to measure the height of a school's flagpole. The student's 5 feet tall, so I made this triangle right here 5 feet tall. Stands up straight, has a shadow of 8 feet, so 5 and 8. And then my other triangle, at the same time a flagpole casts a shadow that's 24 feet. So it goes up, I don't know how high it goes up. It goes out 24. So I have a similarity here to here and here to here. So 5 over x equals 8 over 24. 5 over x equals 8 over 24. So I do my... But what I did here, why I have 1/3, is 8/24 simplifies if you were to put it into the Desmos, or if you were to just go, oh wait, both of these are divisible by 8, divide by 8 over 8, I get 1 over 3. So I simplified this to 1/3. 5x equals 1/3. So I got x equals 15. So what's the height of the flagpole? The flagpole is 15 feet. 15 feet. All right. Find the value of x that makes these triangles similar. Well, what we have here is we have this full length right here. We don't know the full length. We know this little length. So we have the small side. Let's do this one. So we have, because this one is straightforward, we have 3 is to 6 as 4 is to the whole thing. 4 is to 8 as x is to the whole thing. And what's the whole thing? Well, it's 5 plus x. So I could just figure out my scale factor. 3 over 6, well, that's 1/2. 1/2 So the short side is 1/2 the whole thing. Well, that would make this 5, right? Because 5 is 1/2 of 10. 5 is 1/2 of 10. So x equals 5. Could I put it into an equation? Sure. Here's my scale factor. 1/2 equals x over x plus 5. So let's do that. So I have 2x equals x plus 5 minus x, and I have x equals 5. So there you go. 17. Now please recognize that this is flipped over and flipped down. So this 5 goes with the 15. And this x goes with this 4. 3 goes with the 9. So 3 over 9 equals 5 over 15, which equals 4 over x. Okay? So here we've got 1/3, 1/3. So there we go. 1/3 equals 4 over x. So I get 12 equals 1x. There you go. X equals 12. Okay. 18. This folds up, and I don't know if I shared this, but one thing I like to do is I like to find the smallest side and line up with the smallest side. So for here, here's our smallest side, and here's our smallest side. So we have 4 is to 7. As x is to 10.5, as 8 is to 14. So let's see if we have our same x. I'm not sure, but this can be simplified to 4 over 7. Oh, perfect. X over 10.5. It's nice when math works out. So let's just use our scale factor in this one. So we've got 7x equals 10.5 times 4, 42. Divide by 7, x equals 6. All right. So I've got 3, 3. 1, 2, so 3 ends up in the middle here. There's 3, 3. I've got 0, 0. And I've got 0, -3. So there's my triangle. And what I'm going to do is I want to write those. I've got 3, 3, 0, 0, and 0, -3. Okay. And now I have a scale factor of 3, so I have to multiply by 3. The x and the y by 3. Oh man, I got rid of my great red pen. So times 3. So I have 9, 9. I have 0, 0. And I have 0, -9. So my new triangle would be 8, 9, 9, 0, 0, and 0, -9. And these lines are too long for me to get accurate, a nice straight line, so I will use a ruler. And there's my new one. So what about this one? I've got 3, 3, 1, 2, 3, 1, 2, 2, 3, 3, 0, 0, and 0, -3. So here's my original. And then it's way easier to write them down. So I have 3, 3, 0, 0, and 0, -3. And I have a scale factor of 1/3. And so what I get is 3 times 1/3 is 1, 1, 0, 0, 0, negative 1, 1, 1, 0, 0, 0, negative 1. There's my new triangle. All right, last couple. ABC has 40 and 60. So I'm just going to draw 2 triangles. And I have no idea what the triangles actually look like. I'm just labeling with what I know. I have a 40 degree and a 60 degree. Okay. DEF has a 40 and an 80. So someone says they're not similar. What do you say? Well, 40 and 60, that's 100. 100 minus 180, that leaves us with 180. Oops, I'm sorry. 100 minus 180 is 80. You see we got 40 and 80, so that's 120. 120 minus 180 is 60. Look at that, 40, 60, 80. So those are in fact similar. So I disagree with the person because all angles are equal. I'm sorry, all angles aren't equal. I've got a 40 and a 60 because triangles have congruent angles. All right, 22. Here we go. Describe the similarity transformation. So I went from 2 to 4. I went from 5 to 10. I went from 3 to 6. Let's just look at it. So I've got 2, 0. I've got 5, 2. And I've got 3, 3. Well, in my primed, I've got 4, 0. And then I've got 10, 4. And then I've got 6, 6. 2 to 4, well, that's multiplied by 2. 0 to 0, that's multiplied by 2. 5 to 10, that's times 2, times 2, times 2, times 2. So I have a scale factor or dilation of 2. So for number 22, the only thing that happens is I have a dilation of 2. So let's look at these guys right here. Well, straight away I see this pointy, so it looks like it's reflected across the x-axis. And let's see, this point, 0, negative 2. No, that's 1. 0, negative. Sorry. Negative 1, negative 2. So, negative 1, negative 2. 1, 6, negative 6. 4, negative 5. 4, negative 4. So those are original ones. So what if we did each of these by half? I would get 0.51, 0.53. Okay, so we have a dilation, 1/2. So we multiply it by 1/2, and then boop, we reflect it across x-axis. So if we did 1/2 of each of these, I would get negative 0.5, negative 1, 0.5, negative 3, 2, negative 2.5, 2, negative 2. So negative 0.5, negative 1, negative 0.5, negative 3, 2, negative 2.5, 2, negative 2, oops, that's 0.5, so that should be right here. So take that one out. And then if I reflect it across the y-axis, this goes here, this goes here, this goes here, this goes here. All right, there it is. Hope you do well on the test, and we will see you in class.